Hi, I wanted to show you something from the question list of the programming course with Sheminsky, and I didn't feel like writing it down. So the question list is on the board. You should have access to it by now. If you don't, well, I don't even know what you're doing here. So, the things I'm gonna be talking about today now are covered in the second lecture. So this one, but well, I don't care about it too much right now. I'll leave it open so you can see it. Okay, so there's the list. The practical test will be covered because practically I'm on a computer. So we have the first thing is filters. So these are basically the stuff that we were writing all along our labs of programming, and now we are moving to the 1.2. It's been a long time ago. It's the first or second list for the labs. It's the shortest, and I wanted to just show it real quick how you can do this. I've been thinking about it, and I don't think that the sort filter is necessary for that, because there's no sorting things here. But I don't also think that we need find. We need find string, the find str filter for this list. So we're gonna go and do those things. Okay, so we need a command processor, of course. I'm using the Windows in a virtual machine on the OS X, but whatever, it's just Windows. So I'm gonna change the font so we can see clearly what I'm typing. Okay, and I prepared my directory for practicing that, and it's practical, I believe. So yeah, and now let's print it out. So you see what you need: the LC filter and line towards filter. They are both on the board again in the labs thing somewhere around here. Yeah, NS filters. It's an archive and it contains them. So also I've downloaded the Nostromo file, text file, but it can be whatever file you want. I just downloaded Nostromo because it has lots of data that we are gonna play around in this video with. Let me just fit both windows on the screen reasonably. Okay, so yeah, maybe something like that. Yeah, that would work pretty neatly. Okay, so I'll scroll it down even further. Okay, so there we go. The first task is to find the number of all words without E. So to actually show the contents of Nostromo, we type something like that. I'm a huge fan of this because you actually see what you're doing with the data. You're typing it on the screen. I'm not gonna do it because it takes a lot of time, and just goes and okay, I'm gonna hit enter, and you see how long the file is. Actually, your computer's doing a lot of stuff while printing the data out. Yeah, again and again and again and again and again. Control C. I haven't let him finish this, but find the number of all words without E. Basically, every task here you're gonna start with type Nostromo text because you're gonna do it with the data. Then you are interested in the number of all words. So what you've seen, we had lines on the screen. We need the line to words filter provided in NS filters to break down line to words. Yeah, duh. And you need to find the number of them. So if we want the number of every single word in Nostromo, it would be typed out even longer than only the Nostromo file, and then we would count it by LC. It's a line count filter also in NS filters. It's not a system filter. So again, I'm gonna say something about the findstr because it's not in the in what he is saying here that we have available, but I don't think that, I think that's a mistake. He makes a lot of mistakes in these lists, as you probably have noticed already, and actually findstr is pretty essential. I mean, we could do it like finding something at the beginning of the string with only find and sort, but really, oh, I don't even want to think about how to do it. I've started and I needed to take a walk. So yeah, here it is. Basically, we're breaking it into 2 words, single words, and we want to find the number of all words without e. We can use find command for it, simple find command, and find command with this setup will show us every word with e in Nostromo. So let's hit enter, and it goes and goes and goes and goes. Look that the e is here in the single quotation marks, which means that it's case sensitive. Maybe it's confusing, but it's case sensitive. Okay, I'm gonna stop it again. So the, been, have, whatever, arrested, eat, something like that. Everything contains e, but without e we need to provide a switch, v switch for that. So it's inverting, and now we're gonna have every word without e, probably even more of them, but e is pretty common character, so maybe there's less of them. We can check if we have time. We can check how many contain e and how many doesn't. So I've said something about the v switch for the command. Well, you can check the switches like that. It works for every command out there. The switch question mark displays the manual on how to do it. So you see, v displays all lines not containing this specified string. But let me return to find string, because find string is much better, and it takes basically the same arguments, but it's bigger in capabilities. You'll see later. So find string v with e as a string will do exactly the same. Every word without e. Oh, we stopped in the same place basically because it's Giorgio again, or maybe Giorgio appears through. Yeah, probably this name appears through Nostromo quite a lot. So you get this and find the number of all words. So what do we need to do with these words on the screen right now? We need to count them. And to count words, we use the filters applied. lc.x, and this gives us the number of, look how fast it was, without printing the names, the lines. So it's 96,945 words not containing e in them. You can count them without lcx. I leave it to you. And you'll get the same number if you follow it correctly. So that's the answer to the first task. This, exactly this. Okay. So the number of all lines, the second one, the number of all lines that contain the letter J and A but do not contain W. I'm pretty certain that you can actually join the find string parameters, the strings, but I'm not gonna do it because it's easier to look through. I'm keeping it simple. Find the number of all lines, so we are not breaking it to words right now. You have to see basically what you need to do. Find the number of all words without e, the number. LC. So basically you're going backwards. Find the number of all words without e. The number, LC. Without e, find string without e. Then the number of all words, line 2 words. Here you have to just get to it, understand the problem in simple terms. Number, words without e. That's what you need. And actually these are pipelined, and actually the sequences in which you pipeline are exclusive. So probably for some complex problems you could switch them around in places, like line towards could go somewhere here, but not with this one. It's just simple. You type Nostromo, you break it down to words, you find the words without E, you count them. That's how you do it. It's an algorithm. It's like programming, but very simple. Okay, so let's get down to business. The number of all lines, the number lines that contain J and A. Number, lines, J and A. So we are not breaking it down with line to words. I'm actually pointing my fingers at the screen, and I know that it doesn't make sense of me to do that. So type Nostromo text, and then we are gonna find those with J. Find string, because we are gonna stay loyal to this filter. So that contain the letter J. Again, it's case sensitive because it's in the single quotation here. I'm taking it as a character J, not uppercase J, just lowercase J. Find string J without the V because we want it contained, and find string J, then find string A. Okay, maybe I have some habitats from C programming. Type Nostromo, find J, find A. So basically we're gonna type the lines that contain J and contain A in them. The lines again. So let's go through it. And let's take this one. A, and somewhere out there is J. So let's say that we don't want W because there's somewhere probably a line with W in it. Where is it? Where is the W? I know it's somewhere out there. Yeah. Jealous ravings of that men were no revelation. So find string V as a switch because we invert, and W in this. And we don't get this line. We don't get any line with W in it because we simply remove them with this filter. So we type Nostromo, find the lines with J, and just remove every other. Find the lines with A, remove every other. Find the lines that do not contain W, lowercase w. I've spotted this one, but it has to be lowercase. And remove those that contain W lowercase. And then what we do, the number of all lines. So we count them. Oh, you haven't seen that I've typed I'll see into it. So here it is, I'll see. And 185 lines were meeting the condition. Now, the number of all words that start the letter with the letter, again, the mistake. Jesus Christ, what he's doing? I don't know. He's probably drunk making these lists. Nostromo text, then we break it down to words again. Line to, oh, it corrected my case. Whatever. So line to words, we get the words. Now we need to have something that gets the starting position, and this is actually the starting character. So find doesn't have this capability. If we run it like that, there's nothing here saying how to find something that starts the text, the data starts with it. So find str, for the other hand, look at this, it's really short, like 10 lines or something, and find str doesn't even fit my screen. So these are all the switches it takes. You can read them all if you want, but there's a one that interests us. B matches pattern if at the beginning of a line. The pattern is basically the string, and then V prints only lines that do not contain a match. Then E specifies that the search is not to be case sensitive. So this tells that A, lowercase a, and uppercase A are the same shit. So let's okay, yeah, let's do it. Type Nostromo text, and then the number of all words, line to words again, then that start with the letter J or uppercase J, find string, and beginning, at the beginning, case insensitive, J, so it's J or uppercase J, I could write it like that, and it doesn't matter, and then we exclude I or O, and again I'm not gonna join those commands. Find str, and now do not contain the, it's not case insensitive because I is in single quotations, so I find str the O, and these are the words that start with J but do not contain I nor O. Okay, just, jetty, jet, just, jungly, Jews. Judge, jumped, jewel, jewels, just. The Jews are really interesting. Like I said. Okay, so, but we are interested in the number, so what do we type? Yeah, exactly, LC. And there's 286. Go ahead and count those. Okay. Show all words that start with J but do not contain E. With J, I don't know, lowercase, uppercase, whatever. I'm gonna treat it as lowercase or uppercase. So, type Nostromo. Oh, Jesus. Nostromo. Show words. Words. Line to words. Show all words that start with J, do not contain E. Find string. I don't know if I will be able to upload a video this long. Find string. Show all words that start with J. Beginning, right? With J. Uppercase. Let's say that the uppercase. We can make it case insensitive, but I don't want that. And then do not contain E. Find string the E. And show all words, not this, because this gives us a number. This, only this. We show the words. So start with J, uppercase J, but do not contain E. Just. Janta is Janta, whatever. Javira, Jack, John, journalist, justly. Not really much of them, as you can say. How many? LC? Only 68. So that's not a lot. Show the number of all words from the lines. Well, this is where it gets tricky. So type Nostromo. And show the number of all words from lines that contain the word destiny. So we are basically searching for the lines that contain the word destiny. You know, you can just do something like that. The lines that contain the word destiny. Just and then you take this part. So we are working with lines. No line to words. Show the lines that contain the word destiny. Find string. Destiny. It's not in the quotations, so I'm taking the destiny, but I've already checked that the destiny is only from the lowercase letter, so there's no variations for it, but I'm gonna type it, okay? And the word destiny. And this gives us all lines. Wow, 5 of the lines that contain destiny. Amazing, isn't it? And then, what we have to do, show the number of all words from the lines that contain the word destiny. We have those lines. We have to show the number of all words. Let's show the words, right? Line to words. And we have the words. Let's see if it's correct. By this he meant to express his faith in destiny in words. By this he meant to express his faith in destiny in words. See, it's all the same, but in respective lines. And then we count them. Again with what? With LC. 58 words from the lines that contain the word destiny. Okay, show the number of occurrences of the word worlds. it seems really simple, you know, like it should be on the beginning of the list. Why? Because this one is tricky. There's no world's word in the file, Nostromo. I bet he knew that I'm going to be operating with this particular file. So show the number of occurrences of the word words. The number of occurrences of the word. So we have to split to words. So we have the list of the words from Nostromo. And then we reject everything that is not words. Find str B, not V, no. World. This is the word. We can actually make it case insensitive because no, see, there's a it's in the quotation. I'm leaving it like that. It has to be strictly words. No, so not something like, you know, no, I'm not interested in that. Words, only words. Show the number of occurrences of the word words. Let's have it. You know, nothing. No words. So you are supposed to be confused at this point, but you are not dumb. You know that you're doing everything right, don't you? Don't you know that? So we counted 0. Let's count all world. And there's 105. You see, remove the counting, and you have the worlds. Wow. Worldly. Actually, it finds worldly. Show the number of occurrences of the word worlds. So maybe we should get rid of that. Worldly. Because worlds, we could get it. Worldliness. Is there something like that? I don't know. So, this basically works. Worlds, and then we count, and it's 0. But if we wanted to find only worlds, not worldliness, we should actually look at what's going on. You know, we have some longer words like worldly. We have to get rid of that. Let's check how to do it. Because to be honest, I don't know how. So explicitly this. Explicitly. Matches pattern if at the end of a line uses search strings literally. Well, that might be good. The else switch. Is it good? No, it's not. I don't know what that doesn't mean to use them literally. I'm just joking around all my life. So, search for matching files in the current. Okay. Specifies that the search is not to be case. Prints line that match exactly. X. Explicit. No. But it works. You see, only world appears. No deviations for it. X is this switch. Then we count them. The first one returned 105 words. There should be 103. No worldliness and worldly. Worldly. Wow, I have a problem with pronouncing that. Yeah, I'm empty on my beer, so it's sad. Okay. So if you change it to worlds, you get 0 because it's not changing anything. The X is even more exclusive. Maybe that's what it stands for, exclusive. Yeah, probably. So thanks for your time. You know, no, you should thank me for my time. I've shown it to you. Maybe I will present this 1.1 and maybe something more. You know, these are quite interesting. Oh my God, code analysis. Jesus, there's a lot of it. I haven't even looked at it all. So yeah, this is a small part, and it already took 25 minutes. So thanks, and you know, have a good time understanding what I've just said.